Okay, so today we're talking about water quality and how we as a country and a world use different factors to decide if our water is good enough to drink, so the quality of our water. So on your notes at the top where it says healthy water versus unhealthy water, draw a T-chart, and on one side you're going to write healthy water and the other side unhealthy water. So you're going to ask yourself this question: what are qualities of healthy water versus unhealthy water? Take 2 minutes to fill out this T-chart and list some qualities or adjectives of healthy water and then some qualities or adjectives of unhealthy water on the other side. Okay, so feel free to pause the video if you need a little more time with this. Also, throughout the video, I'll be asking you to go to other websites on BlendSpace on different slides of the video. So pause this video at those points and go to the other websites that you need to go to as you go through these notes. Alright, so hopefully on the healthy side you thought of qualities like clear, taste normal, like no taste really, can use for cooking, all those things. On the unhealthy side, maybe you thought like dirty looking with mud in it or bacteria in it or germs in it. Okay, all those would work for unhealthy water. Okay, so what really are the effects? What are the issues and problems that occur when you drink unhealthy water? So you're going to pause this video and go to the next box on BlendSpace and watch this brief clip that tells you about some of the effects of drinking really, really dirty water. On your notes where you have those 5 lines, you're going to record 5 different facts that surprise you as you watch this video. So make sure you pause this video right now and go to the next spot on BlendSpace to watch the video about the effects of drinking dirty and unhealthy water. Okay, so that video you watched talked about a lot of disturbing facts that come with drinking unhealthy water. So it causes a lot of diseases, and finding clean water is difficult for a lot of people in other countries. So we're actually lucky that we have a government that is concerned about our water and our water quality and has all these different regulations and laws to make sure that we have healthy water. So water is a precious resource that must be managed and protected. You know that from the distribution of water that we talked about a few weeks ago, right? Only a very small percentage of our water is fresh drinking water that we can even drink. So we need to be very careful with it and make sure that we're using it carefully. So federal and state governments have set different water quality standards to make sure the fresh water is actually drinkable, that we can actually drink it. So they're trying to keep our water clean and safe. So a few examples of these different laws that they've passed are right here. So the Clean Water Act, that was passed in 1972. The 1970s was when we really started getting concerned as a nation for the quality of our environment. So we really started trying to protect our environment more. So the Clean Water Act was focused on protecting surface water, so that's like lakes and rivers, and making sure those didn't get polluted. Okay, the EPA was also started around this time. That's the Environmental Protection Agency, and they were set up to enforce and set water quality standards. In 1974, the Safe Drinking Water Act was passed, and that actually gave the EPA the power to set standards for drinking water. So they decided what was good enough for our water quality so that we could drink it. What was good enough quality water to drink. Okay, so as you saw, not all countries have these different regulations and laws on water quality like the U.S. has. So this is just a question you need to think about as you're going through this. Should the government have the right to control and monitor, so watch, water quality? So should that fall under the government's responsibilities, or should they just let us figure it out? Okay, so this is kind of a public health issue. Like, should the government be in charge of this, or should citizens, should people figure out how to get clean water on their own? Okay, so the government actually ends up hiring scientists to monitor or check on water quality. So scientists are really in charge of making sure our water is drinkable, is able to be used for drinking water. So scientists measure and test water in field studies, which is when they actually go out, like this scientist is doing right here, and collect water from our drinking water sources, and they use tools like thermometers and water meters to find out if the water is drinkable. Is it good enough to drink? So they use a variety of things called indicators, which are sort of like factors, to determine the health of a water source. So today we're going to go through all these different indicators, so all these different things that scientists check on to see if the water is drinkable. Okay. So in the next 3 boxes, you're going to fill out for each one the different indicators. So you're going to list out the indicators above the boxes. They use physical indicators, chemical indicators, and biological indicators to see if the water is healthy enough to drink. So these are like the 3 categories of indicators. Okay. So in the physical indicator box, you're going to write these 4 indicators that they use. So these are 4 physical indicators. So these are just properties of water that scientists can either observe or measure without changing the water. If you think of a physical property, that's what a physical indicator is. It's something we can observe or measure without changing the actual identity of the water. So they include dissolved oxygen, so how much oxygen is in the water, pH level, so how acidic or basic the water is, the temperature of the water, and then something called turbidity. So we're going to talk about each of these in detail, so don't worry if these words seem confusing right now. Okay, we will come back to the other boxes after we discuss the physical indicators. So the first physical indicator is dissolved oxygen. Organisms that live in water habitats have to get oxygen from the water in which they live. Remember, organisms like animals need oxygen to survive for cellular respiration. So they end up getting it from oxygen that's actually mixed in with the water or dissolved in the water. So every body of water has a little bit of oxygen dissolved in it or mixed into it. So the amount of dissolved oxygen in a body of water is related to the water's temperature. This is really important right here. Colder water can actually have more dissolved oxygen than warmer water. So as water temperature increases, the amount of dissolved oxygen in the body of water decreases. So you're going to draw out this graph in that little space. Temperature is on the x-axis, and dissolved oxygen levels are on the y-axis. So as you can see, at lower temperatures, there's more dissolved oxygen in the water, but as the temperature increases, the amount of dissolved oxygen decreases. Okay, so at the higher temperatures, there's less oxygen in the water. So take a minute to pause this video and make sure you get that graph. So a healthy water source has medium to cool temperatures and high dissolved oxygen levels. So that's what the scientists are looking for. They're looking for high amounts of dissolved oxygen and medium or cooler temperatures for the water. Okay, with low dissolved oxygen, organisms become stressed and sick. They don't have enough oxygen for cellular respiration. So something called a fish kill can happen if the dissolved oxygen level is very low. So a fish kill, like in this picture, is an event in which large numbers of fish die. So in this picture, these are all fish floating in like a pond, and they're floating because they're dead. So this is a perfect example of a fish kill. So you can kind of draw out for that one like some dead fish. Okay, we're going to do 2 multiple choice questions together. You're going to write out your answers to them where it says answer to multiple choice question number 1 and answer to multiple choice question number 2. All right, here's the first one. Dissolved oxygen data for a local river was taken throughout 2011. So here's your graph with the amounts of dissolved oxygen on the y-axis and the time on the x-axis. In which month was the water temperature most likely lowest? So here you're going to have to remember the relationship between temperature and the amount of dissolved oxygen. So let's remember, at higher temperatures, there's less dissolved oxygen, and at lower temperatures, there's more dissolved oxygen. So we're finding the month when the temperature was lowest. So we need to find the month when the amount of dissolved oxygen was highest. So I'm looking over here, and the answer is going to be February, so B. Okay? Okay, which describes the amount of dissolved oxygen in a healthy water system? A, dissolved oxygen is found in low amounts. B, dissolved oxygen is found in high amounts. C, dissolved oxygen stays within a set range. So hopefully you're thinking B, dissolved oxygen is found in high amounts. Okay, you're going to pause this video and we're going to move on to the next chunk of the notes in the next video.